All right, welcome back, 8th grade. We are going to be pushing into a brand new book. It's going to be It's in the System, and it's all about systems of linear equations and inequalities. And so we're going to jump right in to problem 1.1, but we'll take a little preview of this investigation first. So let's take a look. All right, here we go. Investigation 1, linear equations with two variables. So it says solving equations is one of the most common and useful tasks in mathematics. In earlier units, you learned how to solve linear equations, such as 3x plus 5 equals 17, proportions, such as 3 over 5 is equal to 6 over x, quadratic equations, like x squared minus 5x plus 6 equals 0, and exponential equations, such as 2 to the x plus 1 power equals 64. So now we're going to learn about a new situation. So as a problem in this investigation, pose a new challenge. You will learn to solve linear equations such as 3x plus 5y equals 11 that have two variables. So what would the solution look like, and what does the equation look like? All right, problem 1.1. Shirts and caps, solving equations with two variables. So it says the 8th graders are selling t-shirts and caps to raise money for their end of the year party. The profit from the fundraiser depends on the number of caps and the number of t-shirts sold. So here we go. The profit is going to be $5 profit per t-shirt and $10 profit per cap. The goal is to raise $600. So here for part A, it says here, to plan for the fundraiser, class officers need to know how many t-shirts and caps to order and sell. So it says find the profit P if the students sell 15 shirts, 10 caps, 12 shirts, 20 caps, 30 shirts, 50 caps, S shirts, and S caps. So let's take a look at that. All right, so for A1, we have $5 per t-shirt and $10 per cap. So for 1, we have 15 shirts and 10 caps. So basically, I would do 15 times 5. That could give me 25. This is going to be 75, and this is going to be 10 times 10. So that's going to give me basically 100. So in this case, when I add all this together, this amount is going to equal to $175. All right, A2, we have 12 shirts and 20 caps. So I do 12 times 5, it's going to give me $60. And 20 caps is going to give me $200. So it's going to be equal to $260 because we're adding these guys together. All right, A3, 30 shirts, 50 caps. All right, so we'll do the same work here. To add that together. So we're going to get to $650 adding those together. So now we get to number 4, and it has S shirts and C caps. And what we did is we did times 5 here, so that would give me a 5S. And we did times 10 here, which would give me 10C. And we don't know exactly if that's going to be equal to P. So basically, this equation is going to end up being profit's going to be equal to 5S plus 10C. That's going to be the equation we have there. All right, part B. 1. Find 5 pairs of numbers for shirt and cap sales that will allow the students to make a profit of exactly $600. All right, guys, so we have this new approach to these equations. We have to find out what numbers of caps and shirts will specifically add exactly up to 600. So we're going to have to try to do some guessing and checking, try to figure out some patterns that we can here. But some of them we can find out be obvious if we have all hats and 0 shirts, or all shirts and 0 hats. We can try that out first to get an idea and get a start. So let's take a look at those. So we have this equation. We're going to transfer down here 5S plus 10C, but we got to get exactly 600. And all of these up here were either too low or just above. What if I specifically put 0 in here? So if I do 1 where I have 5 times 0 plus, that's going to give me 0 plus what's going to give me 600? Well, I hope I can see that I would be getting like 60 of these. That would be there. So if I do 10 times 60, that would give me the 600. So there's 1. One of the ordered pairs that we would look for specifically is going to be 0 and 60. All right, so now we're gonna try to do some work. We're just gonna play around a little bit here. I'm just gonna try putting in like increments of 10 and see if that works. So let's put over here another option. So if I do 5s plus 10c equals 600, I'm gonna put in s equals 10 here. So if I do that, 5 times 10, it's gonna give me 50 plus 10c equals 600. So let's take a look. So if I just get this out of here, 10c is equal to, it's going to be 550. Divide by 10, divide by 10. C is going to be equal to, let's see, 550 divided by 10 is going to go in 5 times, and 5 there. So C would be 55. So that means that C equals 55. It's another ordered pair. We can do 10 and 55. Got another one of those. Here, I'm going to kind of look off of this specific equation here. Let's try putting in 20. Just kind of go in increments of 20. So 5 times 20 plus 10c equals 600. So this is going to be 100 plus 10c equals 600 minus 100 minus 100. 10c is going to be equal to 500. Divide by 10, divide by 10. C is going to equal 50. So our other ordered pairs would be 20 and 50. We'll go ahead and try one more. Same thing, but this time we'll try s equals 30 for that. So let's try 5 times 30 plus 10c equals 600. This is going to be 150 plus 10c equals 600. Minus 150 and minus 150. 10c equals, this is going to be 450. Divide by 10, divide by 10. Turns out that c is going to equal to 450 divided by 10. It's going to give me 45. So our other ordered pair is going to be there. So lastly, we're going to have 30 and 45. All right, B2. Each answer from part 1 can be written as an ordered pair, the numbers s and c. The ordered pairs SC, which represents points on a graph, are solutions to the equation 5s plus 10c equals 600. Plot the ordered pairs on the coordinate grid like the one below. All right, so I made a graph just like the one that's in the book there, and I've transferred my ordered pairs over. Hopefully you can read that. But basically here we're going to go ahead and plot those points. So we're going to go 0 and 60. 10 and 55, 20 and 50, 30 and 45, and 0 and 120. I mean, that's not right. It's going to be, sorry, 120 and 0 is what it should be. Sorry about that. 120 and 0. All right, so let's take a look at that, and let's actually graph that here. All right, B3. Use the graph to find 3 other order pairs that meet the profit goal. Well, this is the profit goal. So we've got B3 here. I could see that if I go to 40 and 40, that would work. If I do 60 and 30, and then if I do 80 and 20, those are 3 other options. Anything on that line would work. Let's just test that real quick to make sure that it does actually work. So if I do 40 times 5, it's going to be 200 plus 40 times 10, that's going to be 400. So that does equal 600. So that one checks. And over here, we've got 60 times 5 is going to be 300 plus 30 times 10, which is going to be 300, and that equals 600. And then 80 times 5 is going to be 400 plus 20 times 10 is going to be 200, and that checks. So all those ordered pairs would in fact work. All right, B4. Suppose the number of t-shirts sold was on the vertical axis and the number of caps sold was on the horizontal axis. Would the solutions change? Explain. Well, that means if we took this and we flip-flopped them, if we put the shirts here and the caps here, would that change anything? The question in that case, no, it would not change because we are counting by tens on both of these. The line slope may have a little bit of a change, but ultimately none of the solutions would change. So no, no change. All right, part C. For each equation, find 5 solution pairs that would work here, some with negative values. Plot the solutions on a coordinate grid and draw the graph to show the possible solutions. All right, let's take a look. All right, so if I order pairs, I just made a table of values here. So we need to get this. So if I put in obviously 0, that means this is going to be 10. If I put 1 plus what gets me 10? It's going to be 9. If I put 2 in, it's going to give me 8. 3 in is going to give me 7. And 4 in is going to give me a 6. And that's that table of values in order of pairs is like that. And I just realized I didn't follow those directions completely. I didn't put any negative values in there. So what if I did that? What if I put a -1 and -1 here for x? Would mean that would need to be a positive 11. So let's plot those ordered pairs here. So 0 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 and 9. 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 and 7. 4 and 6. And there it is. There's -1 and 11. That's what that graph would look like right there.